So IMDEA Materials, being a material science institute, I think is at the forefront in terms of really putting the material science at the center of the models. So not just calibrating parameters and trying to match what we see in the experiments, but really from the ground up, so using a bottom-up approach of really what's the physics behind it, what's the thermodynamics behind it, and really having predictive models that are really based on the fundamental material science, which is really the core expertise of the institute. Most of the work we do, being additive manufacturing, simulation, and all of that, are focused very much on the microstructure. That turns out to be kind of the cornerstone of material science because different microstructures emerge from different processing or alloys, and then they directly impact the properties and performance of different parts. And the microstructure emerged from very different, very complex processes, and simulation has a key role to play in that, in the sense that you cannot afford to just print thousands or millions of different alloys, looking at your periodic table and just printing them with different processing parameters to find the best one. So you need a model or models to actually be able to predict that and reduce somewhat the number of experiments that you need to find the best alloy that fits your application or the best processing parameters in some way. The way I see things right now, we have bits and pieces and models that are well developed for individual pieces of the puzzle. Right? We have models for processing to microstructure, some for solidification, some for solid state transformation. Then we have other models that relate the microstructure to properties. And now I think one of the main challenges is really what's been called ICME, Integrated Computational Materials Engineering, which is really linking those models together. So how do we build a complete infrastructure to the virtual processing, virtual testing, and virtual design of materials? So really putting all these pieces of the puzzle together to be able to have the complete virtual chain of processing to the performance of the different materials. We have a limited amount of time, limited amount of resources to actually print the things physically. So if we are capable of printing them virtually, we can explore virtually any alloy, any processes that would take, years or decades to explore, and then accelerate really tremendously the development of alloys and processes for any kind of application.